Good morning, everybody. Welcome to Hydraulics and Hydraulic Machines class. In today's lecture, we discuss two important topics. Number one is what are the various heads that we come across in centrifugal pumps? Then, what are the losses in case of centrifugal pump? And finally, what are the various efficiencies related to centrifugal pump? So these are the three small items that which we discuss today. And these are very, very important in the sense that for the one mark questions or for doing any problem, because the equations for doing the problems we get from today's topic. Whereas in the last class, we have given the velocity triangles and equation for work done per second and also work done per second per unit weight of water. So those two last time we have given, and in today's class we give the rest of the equations so that any problem in centrifugal pumps can be tackled with these equations. So kindly, what are the various heads first? Number one, suction head. Number two, delivery head. Combining these two, suction plus delivery heads, it is called as static head. And one more important head is the manometric head. So finally, how many have come? Suction head, delivery head, then suction plus delivery together, we call it as static head. And the last one is manometric head. Let us see the definitions of each of these things and how you are going to really look into them. So today's lecture focus is on the various heads in centrifugal pump. That is first thing. What are the various losses in centrifugal pump, and what are the various efficiencies in centrifugal pump? These are the three things that which we cover today. So let us take one of the others. So first thing is definition of various heads. What are those various heads? Number one is basically suction head. Suction head. Suction head. We call it as small h, suffix s. Second one is delivery head. We call it as small h, capital D. And third one is static head. It is called as capital H, S. See the difference between this and this. Fourth one is manometric head. But this has only, it is summation of hs plus hd. Beyond that, this we don't remember anything. Static head is nothing but summation of suction head plus delivery head. So this is the thing. So what is it? You also can visualize 1 minute. Actually, what is suction head? Just refer to the figure of the centrifugal pump once, wherein we have drawn all the components. If you see first, then it will be very easy to understand the definition. My sincere request to you all is just look at that components part. What is that actually? It is basically, it is the vertical height. What is it? It is the vertical height. From where? From the water level in the sump. Water level in the sump. It may be in the sump or it may be in a well, wherever the water is available, the source, wherever is available from the source water level, from the sump to the center of the pump, to the center of the pump. That means where you are having the eye of the centrifugal pump. This vertical height is called as suction head. Again, water level in the basically from where you are lifting, that means it may be a well, it may be a sump, or it may be basically a reservoir, or it may be a tank, whatever it is, from the source water level to the center of the pump is called suction head. And then what is delivery head? Again, this delivery head is also, it is also the vertical height from the center of the pump, from the center of the pump to the water level in the overhead tank or water level to water level at the delivery point. That is better. Water level at delivery point. So if I want, you want just, I will show you actually simple thing actually. So this is if you take it the shaft, right, right. So this is the impeller like, okay. This is the thing, and this is how the suction pipe which is connected to, right, and this is the delivery valve. From there, it is delivering to a point actually, right. So this is the source of water, source that is a sump or well. So from here to this is what we call it as HS. And again, in this water level, this is the delivery tank. So if you take it, this is HD. You understood now? The from the vertical height from the center of the pump to the water level in the source actually in the sump, this is first is called as this is suction head, and whereas here from the center of the pump to the water level this vertical height is called as delivery head. And what is static head actually? Static head is equal to suction head plus delivery head. This is one of the important thing actually. So three heads which we have covered now, and I will go into the last one actually, the fourth one which we call it as a manometric head, which is very 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 important. Manometric head. This is represented by capital H, small m, capital. So what is it actually? It is defined as, it is defined as the head against which the centrifugal pump has to work. It is something related to the pump capacity, whereas suction head and delivery head are the just exactly the available things in the field. So from the water level to the center, from the center to the delivery point, whatever vertical heights, don't say lengths, it is the vertical height. So that is that we can measure there. But what is this manometric head? This manometric head is the pump capacities. It is defined as the head against which the centrifugal pump has to work actually. So what is it actually? So what is HM is equal to? It is the head imported, head imported by impeller, because impeller does the work on water. Had imparted by impeller to water. Yeah, I mean, when I say water, it may be water or it may be any other liquid, minus losses in the pump. Losses in the pump. So the head imparted by the impeller to water depends on whatever power developed by the impeller. The power developed by the impeller depends on the capacity of the motor with which it can drive the pump actually. So this is nothing to related the site conditions. This is something related to the motor capabilities actually. Suppose if you want to lift only smaller height and if you want to have a bigger horsepower pump, then automatically you are wasting power only. So that is why depending upon the suction and delivery, we choose what capacity of the pump we need to have for our purposes. So that you kindly remember it. This is something related to not something existing. It is something related to the power imparted by the impeller to water minus whatever losses that takes place in the pump actually. So what is this generally when we select it, how we select it? So how we select it, if you take it, what is the head imparted by impeller to water? Already last class we have derived the equation. It is VW to U2 by G minus losses. I already now number of times I clarified to you this VW to U2 by G basically corresponds to the head actually. So see it, it is meters per second. So it is meter square per second square divided by meter per second square. So automatically final thing is what it is in meters. So when we ask head VW to U2 by G actually, kindly remember if you want work done actually into gamma q you have to put it. Then this is one of the definitions. HM is also we can this is one definition actually. The second definition generally how we procure the pump actually we know what is HS for us. We know what is HD. So similarly what is the friction loss in the suction pipe and what is the friction loss in delivery pipe and finally with what velocity the water will come out of this. So all this summation finally leads to the manometric head. So manometric head is such that actually it is the suction head, delivery head, friction loss in suction basic pipe and friction loss in delivery pipe. And finally, it is the velocity head in the basically delivery pipe. So this is the thing. Again, I need not mention once again, HS is the suction head, delivery head, friction loss in suction pipe, friction loss in delivery pipe, plus the delivery head at the end and at the outlet of the pump actually. So these are the things. And one more definition is also there for it is what HM is equal to what is the total head available at outlet minus total head total head available at inlet. What is the total head available at outlet? Total head available at outlet is according to the Bernoulli's equation P0 by gamma plus V0 square by 2G plus ZO minus inlet means Pi by gamma plus Vi square by 2G plus Zi. Please remember, it's nothing but Bernoulli's equation. Total head is equal to summation of pressure head, velocity head, datum head. Like that. Why I put the O's here? O means outlet, I means inlet. Then we know what is the pressure head at the outlet actually. That is what we call it as delivery head. What is the velocity head at the Vd square by 2G plus Z0 is minus Pi means what? Hs and then Vs square by 2G plus Zi. So this is another equation. So I have given three equations to you. The three equations are first once again recollect actually the three equations. Number one is head imparted by impeller to water minus losses. VW2 U2 by G minus losses. Second equation is summation of all the heads starting from the beginning. That is suction head plus friction loss in suction head, say in suction pipe, delivery head, friction loss in delivery pipe, delivery head at the end of the day. What is the kinetic energy at the end? So this is the basically regarding whatever the various heads. So what we define just concluded. Number one is suction head. So that means from the center of the pump to the water level in the sump. Then what is delivery head? From the center line of the pump to the delivery point actually in the water level in the delivery tank. So it is all what heights we measure. It's not the just lengths, it is heights. Heights means the vertical heights. Then what is the other thing? Summation of suction head plus delivery head is equal to what? Static head. And then we have taken up next what is called as manometric head. Manometric head is equal to head imparted by the impeller to water minus losses. That is VW2 U2 by G minus losses. What is the other head? A definition for manometric head. Manometric head is equal to summation of starting point to the ending point, all the heads. What are those various heads? Suction head, friction loss in suction pipe, then delivery head, the friction loss in delivery pipe. Then last, basically, what is the velocity head at the exit. So these are the two things. And third thing is whatever is the total head at the outlet of the pump minus total head at the inlet of the pump is also called as manometric head. So in such a case, what is the total head at the outlet of the pump? That is HD plus VD squared by 2G plus Z, basically ZO, where O basically talks about the outlet. Similarly, HS plus VS squared by 2G plus ZI. So these are the things which we talked about. Then after knowing this, before going to the efficiency, what we need to know is what are the various losses in centrifugal pumps. Losses in centrifugal pumps. When I say losses in centrifugal pump means it is basically during operation. During operation of centrifugal pump, what losses we come across? The various losses that which we occur during the process, during the operation, the various losses, the various losses that occur during the operation, during the operation of centrifugal pump are number one, mainly thing is hydraulic losses. This is what we are interested. Hydraulic losses. The second one is mechanical losses. Number three is leakage losses. I cut short it to only three. What are the various losses? Hydraulic loss, mechanical loss, and basically the leakage loss. Let us take first one, hydraulic losses. What do you mean by these hydraulic losses? What you consider it as hydraulic loss. The various hydraulic losses means actually first thing is the friction loss in impeller, right? Friction, friction and eddy losses. Eddy losses means cross current. Eddy losses basically in guide blades, right? In guide blades generally comes when it is a diffuser casing. That may be one more act. Then friction losses, friction and minor losses, friction and minor losses in suction pipe. Then friction and minor losses in delivery pipe, right? And any shock or eddy losses in impeller due to vibration or anything. So these are the various losses that we come across in the case of centrifugal pump. Then what are the various mechanical losses? Even though I'm not interested in this, just to have an idea as a topic, let us see. Mechanical losses means actually it is the friction between the impeller, friction between the impeller and the liquid which fills casing and impeller. This is called as disk friction. So that is also called as disk losses. Then mechanical friction of the bearings that are there on the bearings and the glands that are surrounding the basically the shaft. So these losses we call it as mechanical losses. Then actually the leakage losses, if at all anything is there, the quantity of water is being lost. That is what we call it as leakage. Leakage is something which we are losing the water. Leakage is something actually leakage. The quantity of water reduces. So this is the third. So how I can show diagrammatically the thing. First example where the power is available for us. First one for us is from the shaft the power is available. This is what, because in centrifugal pump if you take it where it is available, so this is the what we call it as available thing. This is shaft horsepower, right? This is shaft horsepower in kilowatts. If I write shaft horsepower is the available thing, that is what we call it as P. If from the shaft horsepower, if I reduce the mechanical losses, because from the shaft horsepower to from shaft to where it comes actually to the impeller. So this is the impeller power. So this is again I will tell you the thing, but what loss it is from the shaft to the impeller, this is what is the mechanical losses, right? This is the power now available. How much is the power that is available? It is equal to vw2 u2 by g into gamma q, right? This is the second. Then from this what will happen actually, this is the output power. This is the output power. Output power in kilowatts. Output power means at the end What is the equation for it? It is gamma q hm by 1000. This is the final outcome of it. So what is the difference between these two actually? This is hydraulic losses. And last other hydraulic losses, if at all anything is there, that is what we have basically. This is the law. This is static power. Static power. Static power is in kilowatts, and this is nothing but actually it is gamma q into h, static head divided by 1000. So this is other hydraulic losses, if at all anything. Other hydraulic losses. So now you see the figure I have given. This should clear to you. First initial thing that is available is shaft horsepower, right? Second thing, from shaft horsepower to impeller power. From impeller power to the output of pump. So these are the three things that which we should remember. Between these two is mechanical losses. And between these two is what we call it as hydraulic losses. So if you remember this, then it will be very easy for me to go into what are the various efficiencies of centrifugal pump actually. Let us take it actually. Various efficiencies. Order, if you remember, first thing is motor switched on. When motor switched on, shaft starts rotating, and then that shaft actually transfers power to work to basically power to the impeller, and from the impeller it rotates water and it transfers power to water. So that's what I have written actually. Various efficiencies. So various efficiencies in case of centrifugal pump are: number one is mechanical efficiency. In the same order also I will try to write mechanical efficiency. Second one is which is very very important for us. It is manometric efficiency. This is what people will ask. No, because we being civil engineers, nobody will ask regarding mechanical efficiency. But as a civil engineer, our interest is manometric efficiency, especially when we talk about the hydraulic efficiency of a pump. Then third one is the overall efficiency. Now let us 1 minute compare with the efficiencies of a turbine. What are the efficiencies of a turbine? First we take it: hydraulic efficiency, mechanical efficiency, overall efficiency in turbines. Now in centrifugal pump, this is the manometric. Hydraulic efficiency is replaced by manometric efficiency. Mechanical is same, overall is same. So there in turbines, when the moment you talk about hydraulic efficiency means it relates to turbine. The moment you talk manometric efficiency means it relates to centrifugal pump. So kindly remember that. Now let us go straight into the first thing. What is the manometric efficiency? Because I am interested only in this. Rest is only for definition sake. Manometric efficiency. And I represent it by eta mano. It is the ratio of manometric head to the denominator. Numerator is manometric head. To what is head imparted by impeller to water. Water need not be only water, anything also liquid actually. So if I write it, manometric efficiency is equal to, once again we will write manometric head, manometric head divided by head imparted by impeller to water. So this is Hm divided by Vw2 U2 by G. So this is what actually the manometric efficiency. The equation for manometric efficiency is equal to, it is G into Hm divided by Vw2 U2. If you can recollect actually in reaction turbines, for hydraulic efficiency, what equation you use? Almost it is G H divided by basically VW1 U1. So just observe it, what is happening actually. Then this is also manometric efficiency can also be basically defined as, it also can be, it is also defined as, because different definitions. It is also defined as the power given to water at the outlet, basically of the pump, to again the power available at impeller. And write like this, manometric efficiency is also equal to, it is power delivered to water at outlet of pump to power available at impeller. So this is equal to gamma Q into HM. This is out by 1000 if you put it in kilowatts. So this is the outlet actually. What is the power available at the impeller? BW2 U2 by G is what we have written it as. So it is divided by VW2 U2 by G. It is the head actually. Into convert into work done or power. It is gamma into Q divided by, again to convert into kilowatts, 1000 kilowatts. So and this is the second thing. So finally this is one more definition. So this is the outlet, basically power available. This is power available at the inlet. So and if you even put this also, you are going to get the same answer. So you want me to just try it also? I will show you. It is equal to gamma q basically into Hm divided by 1000, right? Divided by then BW2 U2 by basically G into gamma Q divided by 1000. So the gamma Q will cancel, 1000 will cancel. So it is G Hm divided by VW2 U2. That is what I have shown at the beginning also. So finally, important thing is manometric efficiency is equal to GHM. HM is the manometric head divided by VW2 U2. How to calculate VW2 U2? U2 you can calculate by pi d2 into n by 60. Whereas VW2, if you want to calculate, you have to go to the velocity triangles and then finally find out. So these are the things here. Then let us go into the next efficiency. This is mechanical efficiency. Only definition's sake. mechanical efficiency. Mechanical efficiency M, right? It is equal to directly power available at the impeller, power available at impeller divided by power available at shaft, power available at shaft. So power available at impeller is what actually it is VW2 U2 by G into gamma Q divided by 1000 to convert into kilowatts divided by this is shaft horsepower, which we call it as P. So this is mechanical efficiency. The last one is what is overall efficiency, because generally what we require is we may not be asked to calculate the mechanical efficiency at any point of time. Only we may be using it to calculate some of our required things, such as for example q if you if q u and P are known, VW2 we may have to calculate from this. Otherwise, overall efficiency is one of the thing, and manometric efficiency is the other thing that which we use is in the case of problems. What is overall efficiency? First thing is power available at outlet, because final thing is this power available at outlet of the pump divided by power available at shaft. Power available at shaft. So power available at outlet is equal to gamma Q into HM divided by 1000, right? Divided by this is shaft horsepower in kilowatts. So this is what overall efficiency. There, what is the relation between efficiencies? Overall efficiency is equal to mechanical efficiency into manometric efficiency. In case of turbines, we have written the same as overall efficiency is equal to mechanical efficiency into hydraulic efficiency. So these are the various heads and various efficiencies in case of the centrifugal pump. So with this, I will stop the lecture at this point. So today we have concluded three things. Number one is various heads that are available in the case of centrifugal pump. Then second one which we have taken up is what are the various losses. And the final concluding point is the efficiencies in case of centrifugal pump. Thank you so much.
Like, share, and subscribe. Hit the bell icon for more updates.